We are going to solve the Spaceship Titanic challenge from Kaggle using XGBoost algorithm and employing all the help we can get from GPT-3, ChatGPT, and Github Copilot. The idea behind this dataset is that in the future, year 2912, 13,000 passengers are traveling in a spaceship called Spaceship Titanic, and some anomaly happens around Alpha Centauri, and a lot of the passengers get transported into a different dimension. So the dataset consists of the training dataset, which has the passenger ID, where the passenger is traveling from, whether they are in a cryosleep, cabin number, destination, age, whether they're VIP or not, and how much money they spent on board, age, and stuff like that, and whether they got transported or not. So we're going to solve this challenge using XGBoost. Here we are in Visual Studio Code. Let's take a look at our train.csv. As you can see, it's difficult to read. I have installed the CSV to table extension from Visual Studio Code. Actually, it works really well. How it works is you select your dataset, train.csv, and then you go here, make a greater than sign, and then type in table, and look, convert the table from CSV, bam. It makes a new tab. And now you can see everything just so much better. As you can see, this is all our columns and whether if the person got transported or not. Although it only did this first part because it was the only one that was selected. So let's get rid of that. And actually, if we do this again, here we go, you get to see all of them. I'm going to copy some sample data from our train.csv, just like that, the first 5 lines. Going to paste it into a playground, saying sample data is this. After pasting data, I said we will apply XGBoost to this data set to solve for transported column, Python code. We're going to let playground work for us. I just wanted to also mention XGBoost is a library. You can pip install it with pip install XGBoost. Also, you can go to the XGBoost website. I'll put it in the link and read about it. It's a cool, very cool algorithm. It's very fast. Okay, so I copied this code, pasted it in Visual Studio Code. It already had imported all the necessary libraries, but it gave a bunch of errors because you see, we have some data in the training set like home planet, cryosleep. These are true or false. Okay, we need to convert all these to numerical values. Destination is another one, cabin is another one, and VIP is another one, and also name is another one. These all need to be in numerical form. One way to do it with categorical data such as home planet is that we need to know how many options exist under this home planet. I happen to know there's Europa, Earth, and Mars, and also there's NAN, which is just empty. There's no information. So we need to convert all of these into actually independent columns and then say 0 or 1, whether to say a person is coming from Europe or Earth or Mars. So it would be, instead of home planet, it would be Europe, Earth, Mars. So if the person is traveling from Mars, then the Europa would have a 0 under it, Earth will have a 0 under it, and Mars would have a 1 under it. This is called one-hot encoding. Yeah, we need to do, if you wanted to use these destination, VIP, all of these non-numerical columns, then we need to one-hot encode them. So what I did is I said, we will apply XGBoost, right? After this, I said one-hot encode, home planet, cryosleep, and destination and VIP. I said remove name and cabin. First of all, I don't think name has any bearing on if the person gets transported or not. Even if it did, I really have no idea how to approach it. Also, cabin is really complicated. Let me show you. Because the cabin takes this slash form, it's like which deck, which number room, and which side. Like port, the side can either be port or starboard. And here you can see, so this is the cabin number, this is the deck, and this is whether port or starboard. We would have to really isolate all these, and we might just do that, but for this time being, I just removed them. I just asked GPT-3 to remove them. So we are one-hot encoding home planet, cryosleep, destination, VIP, removing name and cabin, hopefully. So this is the code it wrote, actually, and I copied it, and it actually works. Let me show you. Okay, this is the code that I copied and pasted. So it has a few problems. First, we need to import train test split accuracy score. So those are just imports, right, from scikit-learn. We just have to do that. Thankfully, GitHub Copilot takes care of it for us. So we get rid of that. Now, if you run this again, we're going to get a problem, the same problem we were getting last time, because the passenger ID, see, passenger ID has no bearing, and we can't really one-hot encode it. We have to remove it from our data set because passenger ID is just the ID of the passenger. It's like an index. So essentially, where we are dropping the columns name and cabin, I'm going to remove the passenger ID as well. Okay, I have removed passenger ID, and we're going to talk about this just in a second. If we were to run this now, and just this quickly, if you get a model accuracy that is 0.78, okay, this is mind-boggling. Literally took a few minutes, and essentially we just asked GPT-3, they wrote us some code using XGBoost. If we were to go to leaderboard, okay, like we're already halfway. If we were to scroll down, 78 is already like halfway. Okay, there's 2,800 entries and 78% accuracy is almost halfway, I should say. So if it's for a few minutes work, I think this is wonderful. So let's talk about what's going on here real quick. So we are importing everything we need. We're importing pandas, we're importing XGBoost, and we are importing train test split and accuracy score for use. We're going to talk about that. We are using pandas to read the train.csv file and assign it to a data frame, here in this case data, okay? And then now we need to have this data, which is read from our train.csv. Now we need to one-hot encode the categorical data that we found on our data set. Just to remind you, those are non-numerical data that which we can one-hot encode. We have to do that, otherwise the algorithm won't work. So pd.getDummies does this for us. Actually, this is designed just to do that. All we have to do is just give it the column names, and GPT-3 actually did that for us. So now if we were to actually print this, print data columns, let's see what happens. Real quick. Okay, you see, now this is all the columns we have. Home planet Earth, home planet Europa, home planet Mars. Okay, so we have taken home planet and split it into 3 different columns, and the original home planet is removed. Cryosleep false, cryosleep true. So if a person was in cryosleep C, under this column would be a 1, and under this column would be a 0. Also the destination and VIP false and true have been done. So let's take a look at it a different way. So we're going to print the first 10 items of the data. And as you see, it doesn't show all of it, but you can see that, for example, VIP false and VIP true. So VIP column had been removed and false and true had been. So this person wasn't a VIP. So then we put a 1 under false and a 0 under true. So this is how one-hot encoding works. If you have any questions, please give me a comment, and so I can answer it for you. So then we have to drop the name and cabin columns, also the passenger ID. And next we're assigning X to a data, but we're dropping the transported column, because transported column is what we are trying to predict. So in a data set, what you're trying to predict is your output or your target, and the rest of the columns are your features. You don't have to use all of your features, for example, but essentially, except for the passenger ID, all of this home planet, cryosleep, and all the columns except transported are your features. Those are the elements which you use for the algorithm to make a prediction, to see whether, to make a formulation, whether this person was transported or not. So this is pretty much like the prediction. So we have to remove that. And so X will be our feature set, and Y will be our output or target. And after we've done this, we have to divide this data set into training and test data set. And train test split does this for us. It's actually an option from scikit-learn model selection. And this is just the syntax. You give both the X and the Y. And test size 0.2 means that out of the entire data set, 0.8 of them, 80% of them are going to be for training, and 20% of them are for validation. In this case, it just says test size. Random state is just not sure what this is. You don't have to worry about it. After that, we assign a model to xgb.xgb classifier, because this is a classification task. We either get true or false. It's not regression. Regression is continuous numbers. And then we simply say model.fit to train and Y train. This is our features and this is our output. Then we make predictions. Predictions equal model.predict x.test, because we're making, so this is the training. When we fit it, it had already trained. Once this is done, the model is trained. Now it is making predictions on the test data because the test data was not in the training data, so it hadn't seen it. Then we get an accuracy. Accuracy underscore score is a method from scikit-learn metrics. Then we just print the accuracy. Let's just run this again. Here we go. Model accuracy is 0.78. Remember I mentioned we don't have to use all our features. For example, we don't have to use those columns that we had the one hot encode. For example, we have numerical columns already. The room service, food court, shopping mall, spa, and VR deck were all services that existed on this spaceship. And people spent various levels of money on it, like $193 or something like that on VR deck. We can just use those. To be able to do that, for example, I'm going to say only use room service, food court, shopping mall, spa, VR deck, and transport it. We have to use transport it because that is what we are predicting. Here we go. Actually, Github Copilot completes it for us. So we can actually continue right from here. I believe this should work. Let's see what happens. So now we don't have the one hot encoded feature set. So we have reduced our data set. And look, our accuracy didn't drop that much. We are still at 0.77. Alternatively, we could have only used, let's say, just room service, for example, and transport it. Let's see how it works with just room service. So we're trying to predict if a person is transported or not, just based on how much money they spend on room service. And there's a 0.67% correlation prediction accuracy just from the amount of money they spend on room service. But, right? So one feature or one column can go a long way. Next, let's try to unpack this cabin situation. Let's use ChatGPT to figure out the cabin column. Here I had already asked what XGBoost is about, and you can pause the video and read it if you like. But what we're going to do is actually copy some of these columns as a context for ChatGPT, paste it, and then I added split the cabin column by slash, because as you see, it's separated by slashes, into deck, room number, and side, because the first one is the deck, which deck it is, and the second one is the room number, third one is the which side, remember, starboard or what have you. And then I said one hot encode deck and side columns, because we need to do that. The room number is just numerical. I guess we're just going to keep it like that. And let's see what happens. Okay, so to split the cabin by column into deck, room number, and side, you can use the string.split function in pandas. So it's creating 3 new columns and taking the cabin, splitting it at slash. I think this should work. And then this will create new columns, deck, room number, side. Okay. We're probably going to have to remove cabin. All right. And then one hot encode the deck and side columns. Change the get dummies. Yes, this is exactly what we used, what GPT-3 suggested earlier. Let's just copy these into our code. Okay, we just need to change this df, data frame, to data, because that is the name of our data frame. And then we'll print the data.columns to see if it had worked. Let's run. Okay, it did. Deck, room number, and side had been formed. And cabin is still in here, but remember, we're dropping it in the next, when we're actually in this line, so that's good. Next, let's turn them into one hot encoding. I just copied that line of code, put it right here. Again, I have to change it to data, and then let's just print the columns again, make sure that they are still all there. Okay, this worked. See, as you see, we have one hot encoded. Decks A to G, I'm sorry, A to T are now in their separate columns. Side P and side S is in their separate columns. And we're dropping the cabin column right here. So this should work. I'm going to comment this out because we don't want to use just room service. This was just a little experiment we did. We want to use the entire data frame. And let's just run this and see what happens. Okay, we're getting an error because it says now the room number, which we had extracted from the cabin number, is not essentially it's not a number. It's because remember when we were splitting, it was saying that you can use the string that split. So when it's split, room number, although it's an integer, it's a number, string that split turns into a string. We need to convert it back to numerical value. We can do it right here. Here I'm going to say convert room number to int. Here we go. This should do it, hopefully. Let's run it again. Okay, this one was given some errors saying that it cannot convert float NaN to integer. I tried to get rid of the NaN values, but honestly what I found is that there is another way of doing this. When the Copilot made a suggestion, I just pressed Control Enter to synthesize 10 solutions, and there's this other solution which works too. So this one, instead of doing S-type, to do pd.toNumeric, and we're going to use that, and this actually ends up working. And here we go, we got 0.78% accuracy. I forgot what the earlier one was, but now we have all our columns and everything working well. And yeah, so this is it. So we can actually turn this into a submission and submit it, which I'm not going to do. So we have essentially solved it. 78% is not the best. I believe the best submission is 0.87, but it quickly drops. So a lot of people have come to 81%. We have in a few minutes reached 0.78, but maybe let's just try a different algorithm, quite possibly. Let's ask ChatGPT what other. So it's suggesting random forest, light GBM, neural networks, support vector machine, k-nearest neighbors, and logistic regression. I tried using random forest earlier. I just had trouble with the NaN values. I just couldn't get it to work. Then I tried his gradient boosting fire. That worked really well. That actually got almost 81% accuracy. But we're not going to get into that, maybe in another video. I really want to make another one with neural networks using PyTorch. But we'll end it here. I hope you enjoyed it. Please like the video and subscribe for future videos. And take care. See you in the next one.